The Chang'e program is a significant space exploration initiative managed by the China National Space Administration (CNSA). It is designed to examine the lunar surface more closely and uncover the unknown. Throughout history, we'll examine the evolution of the program and its significant milestones. Chang'e 6 mission and objectives. Let's take a look at the details of the Chang'e 6 mission. By understanding the main objectives and identify the scientific goals of this mission, we'll learn what we hope to discover on the lunar surface. Technological innovations and applications. We'll examine the latest technologies used in Chang'e 6 and their impact on lunar exploration and research. What advancements will this mission make in space technology? Scientific findings and expectations. We'll evaluate the scientific data expected to be obtained from the Chang'e 6 mission and its contributions to humanity's knowledge. What can this mission teach us about the Moon? Future projects and space exploration will assess the impact of the Chang'e 6 mission on future space research and evaluate China's future steps in space exploration. Will this mission mark the beginning of a new era in lunar exploration? For Chang'e 6 mission to successfully land on the Moon, the designated landing moment and time are crucial. The landing moment is one of the most sensitive and critical moments of the mission, determined by considering a range of factors. Firstly, the spacecraft's trajectory and velocity are calculated to reach a specific position in the Moon's orbit. This is done considering the Moon's gravitational field and rotational velocity. The spacecraft's trajectory is adjusted to a specific angle and velocity for a controlled descent to the lunar surface. The landing time is also meticulously determined. The Moon's position and the desired landing site are considered in determining the most suitable landing point, taking into account the Moon's rotational speed and orbital position. Additionally, the topography of the lunar surface and environmental conditions are taken into consideration. For example, the angle of sunlight and the positions of other satellites and craters on the Moon's surface influence the selection of the landing area. The landing moment and time greatly impact the success of the Chang'e 6 mission. If not accurately determined, the spacecraft may not safely land on the lunar surface, or the mission objectives may not be achieved. Therefore, experts and engineers work with great precision and consider all possible scenarios when determining the landing moment and time. The successful landing of Chang'e 6 on the Moon is a critical step for the continuation of the mission. The landing moment and time ensure the spacecraft safely reaches the surface, allowing for the collection of scientific data and the successful achievement of mission objectives. Therefore, accurately determining these factors is of paramount importance for the success of the Chang'e 6 mission. The China National Space Administration (CNSA) is the primary organization responsible for space research and exploration activities under the government of the People's Republic of China. CNSA is a broad organization responsible for space exploration, space research, satellite launches, and other space projects. Its mission is to establish China's leadership in space technology and support national development goals. Chang'e 4 is a significant space mission conducted by CNSA. As part of the Chang'e program, this mission successfully landed on the far side of the Moon, a lesser explored area of the Moon, in a historic landing in 2019. With this historic landing, Chang'e 4 marked a significant milestone in humanity's history of lunar exploration. The Chang'e 4 mission aimed to explore and conduct scientific research on the far side of the Moon. The spacecraft was designed to examine the lunar subsurface, measure its magnetic field, and conduct various scientific experiments such as plant growth experiments. The successful completion of the mission contributed to a better understanding of the mysteries of the Moon and provided important scientific data that will shed light on future space explorations. CNSA's Chang'e 4 mission signifies significant advancements in China's space research. This historic achievement demonstrates China's capabilities in space technology and its contributions to global space exploration. Chang'e 4 represents a significant step forward in the deeper exploration of the lunar surface and has made a significant contribution to humanity's efforts to understand and explore the universe. The Chang'e 4 mission aimed to conduct comprehensive scientific research in the lesser-known areas of the Moon by achieving a soft landing on the lunar far side. Among its primary objectives were various topics such as the formation, geological structure, magnetic field, and subsurface resources of the Moon. Geological research, Chang'e 4 aimed to gain further insight into the formation and evolution of the Moon by examining the geological structures on its far side. Specifically, the mission focused on topics like volcanic activity, crater formation, and subsurface structures. These studies help us understand the lunar interior and its formation processes. Magnetic field measurements conducted during the mission aimed to investigate the origin and effects of the Moon's magnetic field. The magnetic field data allow for a deeper understanding of the lunar geomagnetic properties and provide clues about the Moon's geological history. Plant growth experiments. The Chang'e 4 mission aimed to obtain important information for the sustainability of life in space and future space colonization by conducting plant growth experiments on the lunar surface. These experiments test the ability of plants to adapt to the Moon's low gravity, high radiation, and other environmental conditions. Space communication and surface exploration. Chang'e 4 aimed to develop strategies for establishing communication networks on the lunar far side. This is a crucial step towards creating the communication infrastructure necessary for space exploration. Additionally, explorations conducted on the far side of the Moon help identify potential locations for humanity's long-term presence in space. The Chang'e 4 mission is of great significance as the first soft landing on the far side of the Moon with its extensive scientific objectives. This mission has enabled humanity to explore the Moon more profoundly and take significant steps forward in space research. The landing moment of Chang'e 6 is one of the most critical and exhilarating moments of the mission. The planned landing moment is the time window designated for the spacecraft to descend onto the lunar surface in a controlled manner. It marks the time when the spacecraft departs from a specific orbit, starts its descent towards the lunar surface, and approaches the landing area. The landing moment involves a series of complex calculations and coordination. Determining the landing moment of Chang'e 6 takes into account various factors such as the gravitational effect, rotation, and surface conditions of the Moon. The trajectory and velocity of the spacecraft are meticulously calculated to ensure a safe landing on the lunar surface. Additionally, the lunar position and the orbital position of the Moon relative to the targeted landing area are considered to determine the most suitable landing point. The landing moment is carefully determined by experts and engineers, taking into account all possible scenarios. The landing moment of Chang'e 6 is a critical step for the successful progression of the mission. If not accurately determined, the spacecraft may not safely land on the lunar surface or the mission objectives may not be achieved. Therefore, the landing moment is meticulously planned and holds great importance for the mission to accomplish its goals. The selection of two different landing sites on the far side of the Moon is a critical step in the successful planning of the Chang'e 6 mission. These sites must be suitable for scientific research and provide the conditions for the spacecraft to land safely. The reasons for choosing two different sites could be as follows. Diverse research areas. Selecting two different landing sites allows for the examination of different geographical and geological features on the far side of the Moon. This enables Chang'e 6 to conduct various scientific research and explore different aspects of the Moon. For example, one area may indicate volcanic activity, while another area may be filled with craters. Risk distribution and safety. Choosing two different landing sites can distribute risks and enhance the safety of the mission. Surface conditions, slope, and other potential hazards of each landing area should be considered in the selection process. Choosing two different sites can be viewed as a safety measure against possible risks. Scientific interests and data collection. Two different sites with diverse geographical features facilitate the collection of various scientific data. This data provides a more comprehensive understanding of the formation, geology, magnetic field, and other features of the Moon. Two different sites allow scientists to delve deeper into various aspects of the Moon. The selection of two different landing sites by Chang'e 6 on the far side of the Moon could be an important strategy to achieve its scientific objectives and facilitate a deeper exploration of the Moon. This choice enhances the potential to better understand the unknowns of the Moon and take significant steps forward in humanity's space exploration efforts. Chang'e program, China's lunar exploration program, the Chang'e program, stands as one of the nation's greatest achievements in space research. The Chang'e series aims to achieve soft landings on the lunar surface, deploy lunar rovers, and conduct scientific investigations. The success of the Chang'e 3 and 4 missions, which successfully landed on the lunar surface, has propelled China into a significant player in the global space arena. Tiangong Space Station. China's space station program is focused on the development of the Tiangong station. This project aims to advance space station technology, establish infrastructure for manned space missions, and provide a platform for space research. The Tiangong station has marked significant progress in China's space research and garnered international attention in manned space missions. Beidou Navigation System. China's Beidou navigation satellite system represents a significant achievement in global positioning and navigation. This system provides positioning, timing, and communication services worldwide. The Beidou system serves as a crucial resource for military, civilian, and commercial applications, showcasing China's technological leadership in space research. Space launch capability. China boasts one of the world's largest space launch capacities. With reliable launch vehicles like the Long March rocket family, China plays a critical role in space research, satellite launches, and other space missions. The country's space launch capabilities have significant international influence, establishing China as a leading player in the space industry. These achievements in China's space research demonstrate the nation's rapid development and progress in space exploration. China continues to assume a global leadership role in space research and appears determined to advance further with more innovations and discoveries in the future. Samples from the Moon play a vital role in providing a deep understanding of the scientific importance of lunar examples, lunar formation, evolution, and geology. These samples contain crucial information about the composition, chemistry, and physical properties of the Moon. Here are some points highlighting the scientific significance of lunar samples. Solar system formation. Lunar samples can shed light on the geological processes during the early stages of the solar system. The Moon is considered a time capsule reflecting the periodic evolution of the solar system. Therefore, lunar samples provide important clues about the formation and evolution of the solar system. Lunar geology and geomorphology. Lunar samples are used to study the geology and geomorphology of the Moon. Data obtained about craters, lava flows, mountains, and other surface features provide insights into the formation and geological activity of the Moon. This information provides a significant understanding of the nature and timing of geological processes on the Moon. Lunar chemistry and mineralogy. Lunar samples provide valuable information about the chemistry and mineralogy of the Moon. The mineral composition in these samples is used to understand the formation and evolution of the Moon's surface. In particular, the water content and other chemical traces in lunar samples can shed light on the origin and geological history of the Moon, lunar structure and interior. Lunar samples provide important information about the structure and composition of the Moon's interior. Studying these samples provides insight into the crust, mantle, and core of the Moon. This information helps us understand the formation, evolution, and thermal activity of the Moon's interior. Formation and evolution of Earth. Lunar samples also provide information about the formation and evolution of Earth. The relationship between the Moon and Earth plays a critical role in understanding the evolutionary processes of planets and satellites. Therefore, lunar samples provide important clues about the early history of Earth and how our planet was shaped. These points reflect a general perspective, highlighting the scientific importance of lunar samples. These samples are key components of space exploration and planetary sciences, and will continue to be a significant focus of future lunar missions. China's future space missions and plans reflect the country's rapid growth in space exploration and its efforts to maintain a leadership role in space. Here are some of China's important space missions and future plans. Mars exploration missions. China is rapidly developing and advancing Mars exploration missions. In 2020, they launched the Tianwen-1 Mars exploration spacecraft, sending an orbiter, a rover, and a lander to Mars. In the future, China's Mars exploration program likely aims to conduct explorations on the Martian surface and gather more information about Mars's geology, atmosphere, and climate. Tiangong Space Station. China's space station program involves the construction and operation of the Tiangong Space Station. Tiangong aims to provide a platform for international cooperation, scientific research, and human space missions. The Tiangong Space Station plays a significant role as a step towards sustaining continuous human presence in space. Lunar exploration missions. China's lunar exploration program includes the Chang'e series of spacecraft. The Chang'e series aims to achieve soft landings on the lunar surface, conduct scientific research, and explore lunar resources. In the future, China's lunar exploration program may expand to include crewed lunar missions. Space launches and satellite programs. China regularly conducts space launches and develops satellite programs. These programs include satellite networks used in various fields, such as communication, observation, navigation, and scientific research. In the future, China's satellite programs and space launches will continue to play a significant role in national security, commerce, science, and technology. Space science and technology research. China continuously conducts research and development activities in space science and technology. These efforts focus on space exploration, space technologies, and space sciences. In the future, China's space research will continue to make significant contributions to global space exploration and human space missions. China's space programs and plans highlight the country's significant progress in space exploration and its impact on the international stage. China aims to contribute to humanity's better understanding of the universe and to prepare for the future through exploration and technological innovation in space. China's position in the international space race has rapidly evolved in recent years. The country has taken significant steps in space exploration and demonstrated efforts to maintain a leadership role in space. Here are some important points regarding China's position in the international space race. Space exploration and manned missions. China has garnered attention with large-scale space exploration projects such as the Lunar Exploration Program and manned space missions. The Chang'e series lunar missions and the Tiangong Space Station program are some of China's significant achievements in space research. Additionally, future projects like China's Mars exploration missions will further strengthen the country's presence in space. Technological advancements. China has made significant progress in space technology and launch capabilities. The country is one of the world's leading space agencies with the largest launch capacity and has developed powerful launch vehicles like the Long March rocket family. These technological achievements have positioned China as a significant player in space research on the international stage. International collaboration. China has increased its efforts to collaborate in space exploration internationally. Particularly, it has signed cooperation agreements with the European Space Agency, ESA, and conducted joint space research projects. Additionally, China's Tiangong Space Station program serves as a platform for accepting astronauts from other countries and conducting collaborative projects. Impact on the international stage. China's advancements in space research have increased its influence on the international stage. The country has become a significant player competing with other countries in space technologies and exploration. Moreover, China's successes in space research have contributed to its overall strengthening in science and technology. In conclusion, China's position in the international space race is becoming increasingly important. The country has made significant progress in space research and is poised to play a leading role in space exploration. In the future, China's space programs and projects will garner more attention internationally and make significant contributions to humanity's exploration of space. Collaboration strategies, international partnerships. China engages in collaborative projects with other countries in space research, fostering information sharing. For instance, joint projects with the European Space Agency (ESA) have been undertaken, and European astronauts are planned to visit China's Tiangong space station. Scientific and technical exchanges. China organizes various scientific and technical exchange programs to increase information sharing with the international science and technology community. These programs encourage idea exchange, sharing of experiences, and joint research projects. International Space Station programs. China's Tiangong space station provides the opportunity for astronauts from other countries to visit and conduct joint scientific research. This serves as a platform to promote international collaboration in space research. Competition strategies, technological advancement, and capacity building. China works intensively to enhance technological progress and increase launch capacity in space research. The country continually develops its capabilities in spacecraft, rockets, and satellite technologies, boosting international competitiveness. Mars and Moon exploration programs. China's Mars and Moon exploration programs hold strategic importance in enhancing competition in space and attracting attention internationally. Missions like the Chang'e Lunar Missions series and the Tianwen-1 Mars exploration mission underscore China's leadership role in space research. Space commerce and marketing. China seeks to enter international markets in areas such as space technologies, launch services, and satellite services. The country aims to explore more collaboration opportunities internationally by offering competitive prices and services in the space industry. These strategies aim to strengthen China's international role in space research and create more impact in the global space arena. The country continues to consolidate its position as a significant player in space research through both collaboration and competition. Sharing these exciting details about China's achievements and future plans in space was a pleasure for me. I hope this information-packed journey has excited you as well. China's progress in space exploration demonstrates how far humanity can advance in the realm of space exploration. If you'd like to learn more about this topic or stay informed about future space news, don't forget to subscribe to our channel and be sure to enable notifications to stay updated on our latest content. If you have any questions, feel free to ask. For now, farewell and get ready for a fantastic journey into space.